Good morning and once again welcome to my YouTube channel, PSO and Excel International Maths by Mr. Kamoto. And today I want us to wind up on topic chapter 3 of Pure Mathematics 2, and we'll be discussing about changing the base of logarithms. And in this one we will go through some steps, and we are saying that it is sometimes very convenient to rewrite logarithms using a different base sometimes. Suppose that you have log to base a of x, which is equals to m. If you may wish to rewrite this one as an index notation, because this is under logarithmic notation, write it in index notation. Writing this one in index notation is going to give you a raised to power m is equals to x, having undertaken the anti-clockwise movement. Taking logs to a different base, taking logs to base b, let's say a different base b, we are going to have logarithm to base b of a raised to power m is equals to logarithm to base b of x. And of course it goes without saying that the index law applies here, or rather the power law. Use the power law, which says that this gives you m logarithm of to base b of a is equals to logarithm to base b of x. And of course we know what m was. We all know what m was. It means therefore substitute for m, because you can see originally what m was. We have logarithm to base a of x, or rather logarithm to base a of x times multiplied by logarithm to base b of a is going to be logarithm to base b of x. So if you would wish to make originally what we had, logarithm to base a of x, the subject of the formula, we are going to have logarithm to base a of x equals to logarithm to base b of x all over logarithm to base b. It's going to be logarithm to base b of x divided by this one, logarithm to base b of a. And that is just what we have. So if we want to change this base, logarithm to base a of x, we can introduce log b of x and over log b of a. That is a very important piece of information. But we have a special case. We have a special case, which means that if you have logarithm to base a of b, which can be written in terms of introducing log b, logarithm to base b of b over logarithm to base b of a, and this is simply 1 over logarithm to base b of a. That one is easily that way. So we are saying in a special case, if you introduce a base which is b, then we are going to have logarithm to base a of b is equals 1 over logarithm to base b of a. special case, but it is us to choose the base which we need to introduce. Having said that, we go straight to example 14. Let's talk about example 14, whereby find to three significant figures the values of log. Find log to base 8 of 11. And we are going to give these two approaches. We're going to give this question two approaches. In approach 1, we are going to change the base, introducing base 10. We have log to base 8 of 11 is equivalent to log to base 10 of 11 all over log to base 10 of 8. If we follow this method, log to base a of x is equals to log to base b of the same x over log to base b of what was the base. Now this one goes without saying. It's simply, if you get the calculator whose base is automatically base 10, then you will be able to see the final submission to that particular calculation, and you'll realize that this one is simply log to base 10 of 11, or rather log 11, because it captures base 10 11 divided by log 8, the log of 8, and this is simply 1.15. So this is 1.15 to three significant figures as illustrated. The other method, the other approach, you may let log to base 8 of 11 be equals to x. Anti-clockwise movement says that 8 raised to the power x is equals to 11. And of course, now introduce log to base 10. Log to base 10 of 8 raised to the power x is equals to log to base 10 of 11. And this gives you x log to base 10 of 8 is equals to log to base 10 of 11. And x becomes log 11 over log 8, which takes you back to this one, and we're going to have 1.15. Either way, you will get home. I want in the same video to explain example 15. Let's see what happens in example 15. Example 15, we are told that solve the equation. Solve log to base 5 of x plus 6 log to base x of 5 is equals to 5. And in this one, you can already see this one is different base and this one is different base, but they interchange x and 5 and 5 and x. So I mean, it depends on what you want to bring where. But I would wish to make log to base 5 in both cases, because we don't have anything to do with log to base x in the calculator. So if x remains unknown, then we do not have log to base x. And introducing log to base 5 in term 2, in this term now we have log to base 5 of x plus 6, and of course when you introduce log to base 5, this one becomes log to base 5 of 5 all over log to base 5 of x, which resembles this one, is equals to 5, because I would want us to remember log to base x of 5 can be equals to log to base 5 of 5 all over log to base 5 of x. This is now what we you have brought here. And of course, it goes without saying that we still don't know what is log to base 5 of x, and therefore cannot we cannot just solve it further than that. So we must assume we must we must let it assume a different value. So let log to base 5 of x be something like y or x or p or whatever it is. So we're going to have y plus, because this is already 1, plus 6 over y is equals to 5. Cross multiplying, we have y squared plus 6 is equals to 5y. And this one is tending to form a quadratic equation, and let it be y squared minus 5y plus 6 is equals to 0. Of course, it goes without saying you can use the factor method or even the quadratic method, and you're going to have y squared minus 3y minus 2y plus 6 is 0. So we open this, we have y minus 3 minus 2, y minus 3 is 0. It follows that y minus 3, y minus 2 is 0. And definitely you will realize that y can be 3 or y can be 2. But wait a minute. Y was log to base 5 of x. So we can easily say log to base 5 of x is 3. And if you just take the anti-clockwise movement, you're going to have 5 raised to power 3 is equals to x. And this is x is equals to 125. That is one possible value. Or log to base 5, the other value of y can be 2. And it follows that, again, the anti-clockwise movement, 5 squared is going to be x, and it follows that now x is 5 squared, which is 25. So either way, you get home, and this is very important. Example 15, very, very important, because we have changed the base to 5 to let us rearrange our original statement or question to look like it's going to make sense to all of us. But not just that, you would have changed the base to base 10 or whatever you want to be, but then it would have required you change including term 1. There is including term 1. The reason why we brought base 5 is to avoid disturbing term 1 and only disturb term 2, which we have gone very smoothly. So at the end of the day, make sure you get to my YouTube channel, subscribe and share widely, and of course let us move together. All right.